welcome back to another episode. Now, there's a few things you'll notice about this game. For example, one is, this is the game. This is exactly it. I'll even reload it for you guys. I'm actually running a Windows 10, by the way, so if there's any weird, unexpected things with that. But now it's launching it. Hopefully it actually launches it this time. No? It's having problems launching it. Oh no. I've had no problems launching in the past. It may just be because I just shut it down. There we go. It was just because I shut it down. So, it's a little weird when it starts out. It's a little loud, but it's basically Tis-100. Tis-100, whatever you want to call it. It was like, I believe, an old operating system. Now, it's a coding game. It's a really interesting coding game. It's made by the same company who made Space Jam and Infafactory. I can't remember what the company's called though. Let me just Google it. Oh, Zachtronics. Zachtronics made this game. Now, it's a $6, I believe, on Steam. It's about maybe $7. I think it's $6.50 right now because there's a 10% off. Guys, so this is your mission. And you go, wait, there's 15 missions. Excuse me, sorry. But there's actually more because there's actually a specification editor, which I believe you can, as you know, make your own puzzles. And that's really interesting because you can sorry, you can get other people's puzzles, and there's obviously 15 more, so there must be some special thing here, or maybe random puzzles and stuff. And these missions are going to take you ages. Now, you get 3 kind of programs per one, but technically, I guess you could have more, because if you click the open button, which now it's going to hate me because I don't have that. Let me just try to get more to capture here. First monitor. There we go. See Windows 10 down here. So, these are all your text files, as you can see, and I know this looks pretty weird, but it's just how things work, and it's actually really nifty how they store it. So, if you want to, I guess you can have more save files. You just would need to, like, maybe how you organize them and stuff. Regardless, one thing I will show you is that, as you can see, the game runs in a window. So, if you're not liking Windows games, and the game runs at 30 FPS, as you can see here, then you may have problems with the game, but the game literally does not need to run at 60. It's basically a text. It's not even text-based game. It's literally a programming game. You don't need to run it at 60. I'll show you what I mean. Just believe me. Okay, there's also a PDF which I'm going to open up now. So turn off that. Here's our PDF. It comes with it, and you probably need to read it. There's a little bit of story. It's just an old computer, and there's this like, you know, old computer that they found of this old guy, and it's got some weird thing, and there's these little story notes which I'll show you about. Now, the game is difficult, right? It's gonna challenge you, and there's a lot you can do with it. It's actually quite complex. There's a lot of optimization you can do, and it's really interesting and stuff. So basically, it's a really fun game. I've enjoyed it. I've played a decent amount of hours. I've played 40 minutes already, which is pretty good. I mean, and I could definitely see me playing quite a few more hours. I know there's a whole Reddit thing of the best scores. You can go there, even though I wish they had the best scores they could possibly get. They don't, but that's fine. And as you see, there's all the commands here and stuff. But you don't need to remember them, really, because there's actually shortcuts, like a button you can press. There's a few small shortcuts to tell you about. But, guys, we'll start it off. But yeah, there's a whole Reddit thing of the best scores, so you should be fine. Now, let's actually get this on. Okay. Luckily, I remember that, as you would have been seeing the PDF for the rest. Okay, so we actually don't want to go to this yet. Turn to segment. Oh, so if you press escape, you can always click the button here, and that'll open up, even though, obviously. So that's good if you ever need the module thing. So regardless, obviously we're going to start with a very basic one, and then we're going to maybe do these 3, and then we'll do a 4th one. So we're going to start, and we're going to show you how to create a new program. So you just click create a new program, and then this is your program. Now, what you see is this is your interface. There's obviously a few different things that you guys see. You see these boxes. You can write code in them, and the code is simple. It's assembly level, and it's basically that's all the commands you're ever going to use. All the commands that you can use, even, right? And so, for example, the most common one's moving. So you move from a source to a destination. You add from a source. You subtract from a source. All that stuff. Guys, so let me explain. So these are called nodes. And what you want to do is you always want to get value from the in value, and you always want to put it to an out value. Sometimes you got to subtract them, sometimes you go times. There's a bunch of different things you gotta do, and it's how you do these things in the shortest amount of time, using the least amount of nodes, using the least amount of commands, that gets you the best score. Now, how right now Reddit is running it is they're doing it that lowest nodes is like first priority, and then a tiebreaker is when you times the amount of commands you do and how many cycles. And cycles is how long it takes to complete. So that's how it works. So just keep that in mind that when you're building things, you want to use as little nodes because that's really hard, right? So you got to think about using strategies and stuff to use as little nodes. Guys, so we're going to move a value from up, and we're going to move it down. Now what this means is this value here, it's kind of hard to explain, but essentially this arrow holds a value. So when I press step, you see that this value here gets, this like arrow gets like kind of slotted with the value 51. So when I move up, I'm basically saying take this value, right, and move it to this arrow. And then take this value and move it to this arrow. Take this value and move it to X. You know what I'm saying? So that's how it works. And if we run it, you see, that's how it works. But I haven't done A because I've got to do that myself. But you also can see idle times. These are very important because idle times can tell you, well, actually, this bit of code is running idle for 94% of the time, but this bit's only running idle for 1%. So can we like balance out where we're doing a lot of the math to make it a bit better? And but sometimes that may require you to use more commands. So there's a trade-off there. But that would make your code run faster because it means things are idle for less time. Code runs faster. Sorry about my dog being off tonight. So so there's a few different things here that you can see. There's the ACC or accumulator, I believe it's called. Accumulator? I can't remember what it's called. ACC. Just basically, this is your value. This is how you're going to do it. So you move values to this, and then you can edit them and change them. So we can move our value of 51, which is the first value, to here. Then we can change that value. We can modify it. BAK, it's just like having a second one of these, because sometimes you'll need to interchange values, and sometimes you need to like swap them around and stuff like that. So it's just like having a second one, right? And then the mode is, there's 3 modes: idle, run, and write. And read, actually. So run is where it's running the commands, idle is where it's doing nothing, writing is where it's like writing to one of these arrows, reading is where it's reading from one of the arrows. So that's it. And then obviously there's idle time. You see this communication phrase, basically you just can't use these nodes. And this is like if you press debug here, which you can't see my mouse, maybe you do want to see my mouse. Do you? I'll just try it. Is it a bit much seeing the mouse? I think it's fine. But as you can see, it's basically just like a little bit of story. Not important. Alright, so let's begin. So we're going to move the value from up to left. So from this arrow to this arrow. Then move the value, from right to down. Then move the value from up to down. And again, move the value from up to right. And then move the value from left to down. It seems simple. Maybe it seems complex. It gets really, really hard and complex. And I'm only up to the 3rd level and I struggled, right? I actually built 2 solutions, one that took a lot of cycles and one that didn't. So as you can see, there's a few diagnoses that we passed. There's the cycle count, which is how many cycles we did. There's how many nodes we did and how many instructions we did. So that's it. As you see, these are the same. So technically I may not need one of these, who cares? You can also name them, I believe, by, I can't remember, I think it's like this. If you do this and you go name equals hello, I don't know, maybe, yeah, oh, you even, okay, so if you, on your first line, this is where you can name, you can call it I don't know, YouTube, and this just basically says, this line here says commenting, so here we can say this line isn't run. This isn't run. So now we run, it isn't run, it's just ignored. And it goes fast, yeah. So that's quite cool, isn't it? Right? And then, so we got second one, signal amplifier, we'll start a new one, just for example. And what's this wants us to read the value from A, double it, then put it out to A. So very, very simple, we'll just do this. And we don't really care when we modify this value, we'll just go right. But we do want to modify out 1 point. So here, we're going to move the value from left, and then we're going to move to ACC. where they're going to add ACC, and then we're going to move from ACC to down, then move up to down. So essentially what we're doing here is we're obviously moving the value from this arrow, moving it down, then we're moving it right to this node, then we're reading it, and then we're reading it to our value here. And this allows us to edit it, change it, and so on. So then we're adding it, which basically says we add this add variable, as you can see here. It adds, to get this up, by the way, you press F1. And its add variable basically just adds X mount to ACC. And you can also subtract, negate, which basically, I believe, just turns it to 0. I believe. Pretty nifty, right? Yeah. So, is it negate moving to 0? I can't remember. Let me have a look. Because I've got the thing up here. Neg. Is arithmetically negated. So basically, I believe it's just become 0. Can't you say that? So now if we run this, ding 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 ding, then we got 160 cycles. You may notice something here, 160. You go, oh, that's pretty good. Well, that's pretty darn good. I believe that's actually the best you could get. So I believe you can get better with more nodes. But I believe 160 best. Actually, I'll have a look because I've got it up here. 160 is the best, but you can get 84 with 5 nodes. So if you use 5 nodes and 9 instructions, you can actually lower the cycle count. And that's basically to do with the idle times, right? Because if we look here when we're running it, right, what we're seeing here is we're seeing this is idle for 51% of the time, this is idle for 51%, this is idle for 2% of the time. So technically we could be spreading this out more, right? And that's why I believe they use 5, is to spread out more, and then it makes the idle time a bit nicer, and you're obviously cutting in half the time, basically. Okay, so we'll return, and back to the segment list. Now, we're going to go to the differential converter. Now, this is quite a hard one, but I'm just going to show you how to do it. So I'm going to show you how I started to do it, right? And then I'm going to show you how you can advance these. So the first program I built was simple. So essentially, you want to read values from A, and you want to read values from B. And then you want to return A minus B to out P, and B minus A to out N. Seems simple. So all you do is, for here, I went, okay, well, what I want to do is I kind of want to move these values down, switch them across, so I kind of maybe subtract the right value from here, swip them around, then subtract the left value from here, and then move them down. That's what I decided to do. Now this runs perfectly, but the one thing you will notice is it's got 432, where I can get 240. It's also got a lot more nodes and a lot more instructions. Now that one's the most optimized you can get it, I believe, right? But I'm sure there'll be other people. But obviously, again, this is just a little bit of text, so nothing important. It's not relevant to anything other than the story, which there's basically no story, so it's just kind of like a little bit of flavor text, I guess. So here, what we're doing is I'll go for this. So we're moving our value from up to down, and then we're moving it from up to our accumulator or ACC. I believe it's called accumulator because accumulates things, so it makes sense. Then we're saving it, and what it does is it also kind of copies it to back. And what we're doing basically here is we're copying it to back because when we subtract, we'll kind of lose the initial value of ACC. So this allows us to almost kind of like make a copy of it. And then we're subtracting from the right. And what happens over here is we move from up to ACC, we save, we move ACC to the left, right? And that means that now this value is now 0. So then we swipe both of these. So you kind of get what I'm saying? So what happens is when we subtract right, we get A minus B. Then we move it down, and then we swipe, which basically means that back and ACC gets switched. So basically, it goes from like a 0, the initial value, to initial value 0. So I'll kind of show you this. How about I show you? So we'll step through it one at a time. So it first retrieves the value, then it moves the value, then it moves it to the accumulator, then it saves it. Then we obviously move left and subtract right. Right? And then we move ACC down. Actually, technically, I don't need to save. Oh, yeah, I don't need to save it. Guys, we'll keep going. So, we'll go to where we were. So here, we don't need to save because when we move it, we actually don't we don't replace the value, which is interesting. I forgot about that. I forgot that we don't actually replace the value in accumulator when we move something. You just kind of when you move a value, it kind of overrides the value that previously existed. So here, we're subbing right, so 44 minus 93, which is minus 49. And then what we're doing is then we're moving this accumulator down, obviously, to here. And then we're swiping it, so we switch the values. And then we move this accumulator to the right, which this accepts it, gets 49, moves 49 down to here, and then turns the value. So this is actually more cycles. No, is it less? 393? Yeah, so we cut down the instructions by 2, right? 393, and we cut down the cycles. So already there's a little bit of optimization, but we can go even further. Now, this is the better one, and I'm not going to really go into too much detail, then I'll write the next one. Obviously, the next one I write will probably not be very optimized, but hopefully I can give it a go. So we're going to move this value from up to the ACC. Then we're going to obviously move this value up to the left. See, we're only using 5 here. Then we're going to subtract the right value from the ACC. Like what we did before, then we move it down. Then we move the value from up to down. So we just step through this. So we see values. We subtract them. We move the ACC down. We move it down again. Now we move it to the ACC. You can see it. Then we move it. Yeah. Then we move remember, we move the value down, right, to output it. Then we negate it. Oh, I understand. It makes sense now. Negate it. It unnegatifies it. Yeah. That's what it does. And then we move it to the right. Ta-da! Then we move it down. Because I actually didn't write this. This was actually written by me. This was written by a Redditor that I found. I was like, oh, that's cool. But now I actually know what negate means. Now it makes sense, right? I actually didn't know what negate means. That's why I was like, negate 0 ACC. It means reverse the sign. That's so basically. Well, there's a few ways you could have seen this. You could have known that obviously when minusing, depending on what way you minus, you're either going to get a negative or a positive number, but you're always going to still get the same number. How minusing works. Or you would notice them here and go, hey, they're the exact same. They're just one's negative, one's positive. So then you could have negated it, right? But my way was the best from a logical standpoint, because it was like the most, I'm not going to say the most sensical, but it was something that really wasn't relying on the whole negatifying trick, right? So if, for example, you're timesing the numbers, it doesn't matter. It kind of works the same way. So mine works in a slightly better variety of situations, even though theirs was a lot better. So now we're going to begin on the signal comparator. So I don't know, maybe like 340 and like 3. So I want us to read a value for in. Okay, write 1 to out G if it's greater than 0. Write 1 to out E if it's less equals 0, and write 1 to out L if it's less than 0. Now, so we're just going to start off by very simple. Move up, down. Okay, you can, by the way, press Control and then use arrow keys to move your thing around. Control, then arrow keys. Very useful. Move from up to down. Move from up to right. And then, oh, this is where we need it. Jump to label if A is greater than 0. So JGZ, what's the label command? What is it? Damn, I can't remember what the label command was. Is this label? No, okay, it's do, I think. Yeah. And then what we want to do is then we want to move left. And then J, what's this one? Easy, do. Oh, so this is where I was going. This makes no sense. We first have to move left ACC, and then yeah, that's what I was like looking at it again. This isn't alright, but there we go, Vito eventually. I mean, this is the first time I'm ever doing this actually, so keep of me if I make stupid mistakes. Oh, damn it. I always do that first one. There we go. And then we can just move ACC down. Now, you may go, hey, wait, why shouldn't we be checking? No, there's no need to check, because the fact is, if it's not greater than 0 and it's not less than 0, what could it be? It has to be less than 0, so there's no point checking. It's a useless statement. So then we just move ACC down. Actually, move 1 down. Move 1 down. Is this what we do? I think that's what we do. When A is not written to an output, write it 0 instead. Oh, yeah. Yeah. I think I got it right, but like... Ooh. Else we want to move 0. Do we need to do another JGC? It doesn't seem right. Can we do an else statement? No, we can't. We should just be able to... I'm just thinking, should we just be able to... I would assume that we could just hopefully do a check. Do we need to do another check? Oh yeah, because it'll jump, it'll miss this line. Yeah, no, this is fine, don't worry. Because when it jumps, it will miss the line, so it means now we can also move 0 down. See, I'm just on fire today. Apparently not. So, 2 moves down. Move left the kilometer. Down. I understand why. If we move it, then we also actually have to move 1 down, and we also have to move 1 right. Yeah. It's a weird thing. Yeah, so we actually do need to do this command. Damn it. I was really happy, but then I realized, oh no, we actually do need to do it. So what's the command again? LZ. JLZ. Do. See down. That should be all we need to do. Still a lot of errors. Let's have a look. Okay, 1 goes in here. We write 1. This one should be 0, but it's not. Oh, do we need to then negate? It should be fine. Yes, so we move 1 here. Why is it moving 1 down? It shouldn't be doing this, damn it. This should be how working. Jump to label if AC. Is greater than 0, then jump to do. This should work. Oh, will it actually run? Oh, it may not actually run. Oh, I understand how it works. Okay, I just have to read the document thing. Yeah, that makes sense. So start JZ do, right? This is if JZ do is false. So we should run JZ do, and if JZ do is true, then it's going to run this command. Else if JLZ, then we run start. Maybe? I think this looks right. Actually, no, this doesn't matter. Next. J. Oh, no. Maybe we can just run start here? Maybe run a jump start. More errors. Okay. I bet you guys are over this by now. It's like, okay. Oh. Um, oh, this makes sense. Maybe. Next. Well, I don't know why this is. There we go. There's more arrows, of course. I know this. Okay, we just go read it. Well, I don't know why it's trying to do this. It's like trying to set the values here, but we don't want it to run this. Oh man, I don't know how the conditionals work with this. This is the problem. Maybe I just do the whole yeah, I think I could do this. Oh yeah, don't be stupid, just do this. Oh, I'm like really stupid here. Holy cow. There we go. This should fix it. Used to this. There we go. It's like really late, so. Nope, still won't. What did I do? Jump next. Oh no, it's because starts right here. I was like, that's not good. But it's no, it's only this. Nope, still a problem. So we get the value. JZ do. Right. Yes. Yes. What was that? Damn it. Okay, so we're moving one over here. Why are we moving one down? There's no reason for us to do that. Oh. Oh yeah, oh, then we just want to jump to start. You did it! There we go. And we didn't get a bad score either. We actually got a decent score. We went over in the instructions, but looking over at these people, someone got 1336, so smashed me, but took 11 more instructions. Another person got 200, so smashed me again, but I got 5 nodes, so someone got less nodes and less instructions. It looks like you can do in 6 nodes. So maybe, I mean, how would we do this in 6 nodes? Because that's 6 nodes. I don't understand how you can get 5. Maybe you can go through the debug. Maybe. This is a good one though. So hope you guys got a good a good look at the series. And obviously I stuffed up that last puzzle a little bit, but I think we still completed it. Maybe we'll just kind of do a start one. I don't know. It's kind of cool. But here we're actually doing when something a value is equal to this, and that's JRO, I believe. Ooh. This one's actually quite interesting. Read in A when in S is equal to magnitude 1. So if it's equal to 0, then we don't do anything. Oh no, that's easy because it's just less than 0, greater than 0, and 0. Okay, well this one's quite easy too. I'm sure you could... should we do it? So we do that check. They both come into S. I mean, it's interesting because we could do it. I think we'll do it. Let's do it. This is gonna be fun. So move up, down, move. Yeah, I know you can do it in like 5, but I'm gonna do a bit more. I'm gonna do 7 here just to make it easy to understand. But you can like you can just move straight to here. But I'm actually gonna move this way. Though actually, I don't need to. Move left to back. And then this is where we basically have a bunch of jump commands. So we have a thing called if J and Z. So So if J G Z. So it means it's going to be equal 1, or maybe the first variable is not 1. So we might as well do if J is LZ. Then what we want to do is now we want to do a label, and we'll just call this less. Oh, sorry, less. It will run less. Otherwise, we will run. If it's greater than Z, then we'll run more. Otherwise, we will run nothing. Oh, okay. What is it? What happens when it equals 0? Jez, okay. Okay. So, this is cool. Nifty, yeah, I'm excited. So what we're going to do, if it's less, then what we're going to do is we're going to move left to ACC. Because we don't care about it anymore, right? Then we will move, actually maybe just move left to down. And start. Move left to down, jump start. We're going to have to use up all the room. Right, down. Oh. So, what do we want to write? Oh yeah, now we're gonna add these. Can we actually even do this? Left, down, right, kneel, jump, start. Oh, we can. Yeah, we can. Yeah. We got 3 lines here. Yeah. Move left, ACC. Add right. Move ACC down. Damn it. Damn it. Okay, we got a bunch of negative values, but we still did something. We read 7. It's more, so that means we're moving right. So we're less, right? It's hard to follow these things because of how they work, the cycles. So we're just going to follow by the code. 13.7. Okay, 13.7. So it's less, so we're going to take 13. And then we're moving 7. And then we're going to jump start again, and then we're going to move up. See. Now we this should be 7. So we read as 7. Oh, that's why. And we got syntax here. We got a few errors, but a lot less. I think it's our first 0 that we actually got it. So here is our first 0. ACC. Add right. Move ACC down. Oh, that's why. And we can't do another jump start. No. Okay, it's gonna be bad. Oh, this is bad. We need to fit another command in here. Can we actually fit jump start in here? We need like one more line. Man, this is difficult because we need to fit one more line in. Can we remove start? Is there a I'm gonna look. Is there a command that would just go to the start? Yeah. This is difficult. What do we do here? Like, because we got to finish another line. Breakpoint. Because what we want to do is we want to see if we can shorten this down, and it'll work perfectly if we can shorten it down. If it's less, then we go to less. If it's more, we go to more. Is there a way for me to like move this and just say jump 0? Can we just jump to a specific line of code? Is that possible? Oh, we can make labels on lines of other stuff. Sweet. Oh man, that was like that was a close one, because I was like, what do I do here? And I think it's kind of stupid that you have to, that the only solution for that one is the fact that you can actually do it on more than one line. I guess that just seems stupid to me. Oh, I gotta check, see if I went good with that. It was called the signal multiplexer. 153951. Well, I didn't beat in cycles, but I did get the best. Oh, I didn't get the. Damn it! I didn't get the 100% best score because some people did it, but I got really darn close. I got the same amount of nodes. I did it the fast node way, but I didn't get as many cycles. They got better cycles than me. And they got less instructions. I don't know how they got less instructions. Maybe they did like this. Like that. Move. Oh man, just control base. There we go. And then less. Oh, because you can't spell right. Oh, but you can go move left down. So we're just going to Control Z this to what it was before. Then we're going to make this as short as we can. So, what's the shortest statement? They're both the same. Move left nil, move right down. Left and nil. Oh, I see. That's sure enough. Yeah, no. You can't do anything there. No. Maybe this will be better. 282 17. Yeah, no. It's still no. That's really no. It cut off 2 somehow. I don't know how they cut off 2. Because otherwise, if you don't get rid of it, it won't work. Maybe? Well, we don't need this anymore. Doesn't make any difference. So maybe if we get rid of it by commenting out, and then like calling this out. Yeah, no, we go wrong. As I thought. So you need it in there. Oh yeah, you don't need to save. But you gotta be careful, maybe. I don't know how you could make this quicker. Maybe you guys know 2 commands, it's quite a bit. Start less, more, left ACC, add right, move ACC down, jump start. That's interesting. Maybe, I don't know. Well, that worked, and I'm really happy with that. That was actually a really happy program. I actually got really close to obviously the top. As you see, I was only a little bit off. I was off, and by a little bit, but I think I got so close to the solution. I think it would just be a bit more optimization. Now, I think that was really cool. I gotta say, anything else? Not really. That's the end of the thing. The game is great fun. It's actually really good, and try it out. I know this video is a bit longer, but I felt it really kind of needed it because it's a really interesting game that really has quite a few interesting puzzles. Anyway, see you guys next time.